Hey, we're going to find the volume here. It says find the volume of the region bounded by y equals the secant of x. Probably not something we're used to graphing, so I went to Desmos and pulled the graph of secant of x, at least for the region that we're looking at. Y equals square root of 2, and in the x values negative pi over 4 to pi over 4, and we're going to rotate that around the x-axis. So the first thing here, we're going to take something and rotate it around the x-axis, so that means everything needs to be in terms of x. The line I have up here, the curve, was the secant of x. So let's be very careful here because it says we want to cut this thing off at y equals square root of 2. Square root of 2 is about 1.4 or something, so I'm just going to estimate it in here, but it comes across here, y equals square root of 2. And we're going to do x from negative pi over 4 to positive pi over 4. And I believe that is where the secant of x equals the square root of 2. But that's a little bit less than 1, or right inside 1. So I think we're talking about right in here. So if we talk about the region that we're going to be rotating, it's in between the straight line and the parabola up here. And when we rotate it around, just to kind of make sure you're okay with it, you'll get a region down here as well, but it'll come all the way around. But keep in mind, we're rotating a figure, so you'll have something that comes around three-dimensionally. I cannot draw it, but it'll look kind of like a wristband or something like that. It'll be like curved inside and flat on the outside. But from the line of revolution here, okay, which is the x-axis, let's see what we can do. We said everything needs to be in terms of x, so let's just kind of talk about things. Our big R, which is our outer radius, will go from the x-axis all the way out to where y equals square root of 2. So that outer radius will be square root of 2. That's our outer. Oops. And then our little r, which is our inner, will go to the parabola, which is secant of x. Okay, so we have our little r to the inside of the yellow region and our big R to the outside of the yellow region. I'm sorry if you hear a dog drinking. So we'll set up our integration. It'll be pi from negative pi over 4 to positive pi over 4, 45 degrees, but that won't work if we actually have variables without trig functions. Let me wait till the dog's done. Okay, I'm back. Sorry about the dog noise. Let's see here. The outer radius will be, square root of 2. And we know that's going to be squared. That's our big R. And minus secant of x, that's our inner radius, that's going to be squared. That's nice because we know how to integrate secant squared, dx. So just to rewrite here, negative pi over 4 to pi over 4 are our bounds, but it'll be 2 minus secant squared of x dx. So a very simple integration. So pi on the outside, it'll be 2x minus tangent of x from negative pi over 4 to positive pi over 4. And this will be interesting because you haven't had this happen anytime recently. So when we let x equal pi over 4, we get pi times 2 times pi over 4 will be pi over 2 minus the tangent of pi over 4, which that is 1. Tangent to pi over 4 is 1. And then we're going to have minus when we plug in the negative pi over 4. So we'll have pi times negative pi over 4 times 2 will be negative pi over 2. And it'll be minus tangent of negative pi over 4, which is negative 1. So this is the case where this last part is not going to be completely 0. So let's clean that up a little bit. The first one will be pi squared over 2 minus pi. The second one I'll distribute the negative in, so it'll be plus pi squared over 2 negative 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 minus pi. So in the end, it looks like we get pi squared minus 2 pi. That seems familiar from a problem we've done before. Just to make sure I can get a decimal approximation, pi squared minus 2 times pi looks like it's about 3.586. Okay, if you want a decimal approximation. Alright, so it looks like a pretty thin region going around there, so not a lot of volume.